Thank you so much everyone for joining. This will be definitely focusing around Kubernetes security. We kind of start with looking at the different kind of attacks in the MITRE framework, like from initial discovery to complete impact and what kind of different layers of attacks we see. Then we kind of mainly focus on how we can see it differs from generic detection engineering from the traditional world, like coming from the VMs or cloud world to containers, like what you have to look at mainly specifically so that you can able to detect Kubernetes or container based attacks, right? So a bit about me, myself Madhu Akula. I've been fortunate to speak at a bunch of conferences like Black Hat DevCon and some of the other developer and DevOps conferences. I've been also created a bunch of open source projects. One of them we might see today called Kubernetes Goat, which is a vulnerable playground to learn and practice Kubernetes security. And yeah, that's pretty much. I keep learning new things. So if you want to follow me, whatever the research I do, you can follow me at Twitter, Madhu Akula. So that's pretty much about me. So this is kind of mostly we look at different attacks, but we also see a quick demos in different layering style, right? So before moving on, so how many of you are aware about like containers or Kubernetes? Maybe if you just, awesome. Yeah, I think I don't have much job to worry because I'm a bit worried like the audience wise. So I put a bit of slides from the basics. But if you don't mind, I quickly move on to the fundamentals, maybe everyone in the same pace, right? Thank you. Cool. So the whole momentum of like containers has come up with one of the key concept of Docker. I think if you are someone using Docker for a while, they used to call something called .cloud, a bigger company before the name. So the only biggest reason I think I just put it in a way, the developers used to say, oh, it was working on my system. I don't know why the application is not working on server, right? So that's the whole point of Docker is trying to solve, right? So you build an app, it working on developer laptop. I wanted to make sure the same app works in anywhere. It doesn't matter it's in Raspberry Pi or container or cloud or anywhere, right? So that's the whole point of how Docker got adopted so well, right? So if you look at like the simple graph or like the momentum or transition, like we have a hardware operating system, you build a bunch of applications. Slowly we move to like hypervisors, like if you look at like Zen and like Proxmox, like, or like if you look at desktop, maybe it's a VirtualBox or VMware, right? So where we have a bunch of virtual machines, then you have again operating system like Ubuntu, then again you have binary, then you have an application, right? So the only part it is changing here is, so we have something called container runtime, which is basically, if you think of this as a Docker, but given I think it's been a year, it's matured. So there are a ton of container runtimes available right now. So basically you just use the app and package with all the libraries required, which means all the dependencies, packages and everything. Then you just run it, right? So what it does is it basically uses still underlying kernel resources of the operating system, then run the app like as is, right? So that's a extremely high level. By the way, I'm not going deep, like, yeah. So some of the things it is trying to solve is basically, as I said, like it's basically once you containerize the app, it can run anywhere. It doesn't matter wherever you want it to run, right? And the biggest thing also, you can ship it easily, like how you just give binaries, like you just give a Docker container, just pull it and run it anywhere, right? Cool. Then, okay, it's all good, fancy, it's working. Then why Kubernetes? Because it's another buzzword, like especially from security people point of view, right? So the biggest problem Kubernetes want to solve is, okay, if you have one Docker container, okay, you can run it manually. What if I have thousands of containers, right? Maybe I want to run for like Dutch NN, right? Maybe they wanted to scale up and scale down in a matter of seconds, right? So that is where you need to manage some kind of orchestration, right? So Kubernetes is nothing but a simple orchestrator. There are, by the way, a ton of orchestrators out there apart from Kubernetes. So the reason it became so popular and became buzzword is because it is so portable. You can just extend your workload once you containerize and manage throughout the life cycle, which means if you want to scale up, scale down, load balance, manage the traffic, basically you are reducing a lot of engineering time by adopting these things, right? So yeah, this is extremely high level, like 30,000 foot view. You can think of how Kubernetes cluster looks like, right? Like an architecture point of view. So it doesn't matter anyone trying to talk to Kubernetes. So they basically has to go through something called API server. Think of this as a key component to the Kubernetes, like a brain or something, right? So it doesn't matter if some attacker is talking or some user is talking, developer, or even some of the applications within the Kubernetes has to go through something called API server, right? So if you think about attacker, for him also it's special, right? Or him or her, sorry. So then Kubernetes API server become a key core part of the thing where you want to attack or target as an attacker, right? So some of the other components is something called control manager, which is basically think of that's like, okay, I have so-and-so node, can you schedule this pod or Nginx application in one of the place, right? So it'll go and figure out, okay, it'll ask API server, can I schedule this Nginx pod somewhere? Like it's a container is nothing but a small unit, right? So scheduler job is basically a manager of hotel, right? Oh, do you have a booking? Can I check? Oh, we have these many rooms available. Okay, you can go on this 1 bedroom or like 2 bedroom, whatever the thing. So scheduler will figure out how much CPU memory required. It'll go and figure out the system and go and deploy those parts or systems, right? So the final piece is, this is quite interesting. HITB, which is nothing but a database or key value store they call. It's nothing but a key value pairs like key value. It just stores in the entire like a Kubernetes related resources in a key value database, right? So if you look at an attacker's point of view, this is also a target. If someone can able to gain or manipulate database, basically you manipulating the whole cluster, right? So there are a lot of moving parts, especially in the distributed system nature, right? And these all like a master node or control plane they call, which means only administrators will manage. Whatever the workloads, whatever you deploy applications and running all the fancy web applications is getting deployed in worker node, which is where like the containers get run. And if you see whatever we've seen, the container Docker is just this part, small part, the container runtime, right? So if you like, so many components are there, I definitely don't want to touch them right now, but we will see some of them while going through some of the attacks. Cool. If you're someone completely new, this is a really fun way to learn Kubernetes. It's using some like a VP. There is a video by CNCF. Please make sure to watch. It will be fun to learn, like a very fundamental way to learn Kubernetes. Right. Cool. All good. So why security, right? So if you look about Kubernetes security, right, it's not as same as traditional security, right? The biggest thing, at least in the security team, at least I have seen, I've been doing Kubernetes for a while, is the knowledge gap, right? It's not just with Kubernetes, any systems, right? Think of this, there is a cluster hacked and you, a security team trying to just delete a pod, right? In a Kubernetes world, it can spin up another pod in a matter of seconds, right? By the time you patch or delete the pod, another pod might have spun up and the same attack is working in a persistent way. So this understanding these concepts and terminology is so important. It doesn't matter if you wanted to attack or hack or detect them, because that gives a lot of context when you wanted to protect them or hack them, right? The biggest other challenge is it's so rapidly growing. I don't know if anyone familiar with something called cloud native landscape. It's not a buzzword, by the way. There is a huge conference going on called KubeCon. I just spoke yesterday. So basically, there is ton of components by Linux Foundation runs, like these all are the projects, basically $1 billion industry used by all the enterprises at different projects, right? So it's rapidly growing in a market space, right? So which means you need to adopt as a security team, how can I use this technology so that I can able to hack and detect these, or like maybe go beyond something, right? So this is, by the way, it's not at all trying to blame security teams. It's even with the DevOps team, they couldn't catch up with these things, because by tomorrow you see 4 shiny object tools coming out in the market, right? So yeah, one of the thing is, if you don't understand the technology, sorry for that, you can't secure it, basically, right? So if you don't know what is like a pod, what is the distributed systems components, basically what you are trying to do is same traditional concepts. It may not work in the Kubernetes world or like modern systems, right? But to be honest, nothing to differ. If you understand them and map it back to traditional security, these are nothing fancy. It's like same, like a words or terminology. I don't know if you are coming from traditional world, like data center VLANs. In cloud, they call like VPC peering or subnets or security groups, right? Same way they call like network security policy. So just terminology will change, but the fundamentals will still apply there, right? So that's what I say. Like if you don't understand the technology, basically you can't secure anything, right? Cool. All good, right? And also you see a lot of popular attacks happening, right? Like for example, HackerOne, like Shopify got hacked the entire clusters because a simple SSR vulnerability. From there, they took over the cluster, right? And you see someone trying to run an entire CTF on Kubernetes, because it's very long back, by the way, and besides SF, they were running in Kubernetes cluster. That time Kubernetes itself not matured. So by default, if you get a token or back, you are cluster admin, right? It's not the problem with, by the way, the people who deployed, the way the system is built, because it's not matured ecosystem right now, right? And there is a lot of people, you have seen crypto miners with the fundamental nature of containers. It became so popular. So there is a lot of attack space also extremely growing. So definitely you need to think about this in a way, right? So I just brought you some very fancy way, but it's not that fancy. It's a standard good old technique of MITRE attack framework, right? From initial access to how you see the impact in the clusters, right? I just wanted to map it back to the Kubernetes and see how we can detect some of the attacks and see some of the real world hacks, right? By the way, this is initially created by Microsoft. But I think we will be borrowing some of these scenarios, and some of my engagements have been doing quite a lot of research for almost 6 years. So I have created simple attack flow from initial discovery to complete cluster takeover in different stages from some of my engagements and hacking, whatever the exercises I have done, right? Cool. So before we dive, I just want to talk about something called attack path or kill chain, I call. What it means is basically from you wanted to start taking over the world to basically impacting the whole cluster. There are so many if-else conditions, right? Loops. So we kind of pass through some of these things and see how we can go through a real world cluster hack from completely nowhere you see anything to complete cluster overtake. So rather we have less time, so I better dive into the demo. So I'll try to stop and explain some of these stages while going through the demo, right? Cool. Definitely, I love to do hands-on demos and I love to do live demos, but given the time I have 30 minutes, I couldn't able to do this because it takes almost 40 minutes. So I had to record in and 2x speed for you. But yeah. So let me just quickly do the demo for you. So if you see here, this is basically, I hope you can see the font. Cool, thanks. This is basically a 3-node Kubernetes cluster. So we're just trying to see, okay, can you basically get the list of nodes? If you look at this, right, maybe I'll try to map it back with, I don't know, some diagram, right, which we had. I forgot where it was. Yeah. So basically, these are the things, nodes we are trying to look at right now, right? So, basically, we are trying to take the list of nodes which are available in the Kubernetes cluster. These are the 3 nodes cluster. It's a 3-node Kubernetes cluster. And I also wanted to see what is the master node, which is the API server. As you remember, like master node is nothing but it has all sensitive stuff, right? We want to target that as well. If you look at this is not a fancy thing, good old nmap scan I'm started with because I just know that something called a node port, which is one of the things specific to Kubernetes concept. Right? What it means is basically if you expose any application in node port, which is by the way, very simple config mistake, right? Which means whole Kubernetes cluster get exposed to the world by bypassing whatever the technologies they put, API gateways, firewalls, or like WAF and other things, right? So understanding technology is important. So that's where we started, right? So once we started scanning the basic cluster, we know there are a bunch of node ports exposed. So we started hitting the one of them, like standard old like application security testing, right? So as a tester, okay, I'll see, oh, this is interesting, an application. I'll start enumerating what kind of attacks I can think of, right? Okay, it looks like a ping, right? Definitely, I don't want to show web application attacks because you all are much more better than me. So I just wanted to start from once I started as an attacker from external facing. Okay, I think this has a remote code execution. So I found after doing a lot of enumeration and thing, okay, there is a vulnerability of remote code execution. By the way, these all are collection of vulnerabilities I found in different clusters. So I try to showcase a kill chain for you. So assume that once you have like a initial access, you got into a container. So if you look at this in a way, I don't know which place we are in. Yeah. So think of this. We came from here outside completely to one of this pod here, which means container. Right now we are here, right? So let's see from there where else we can go. So once we are inside a container, as an attacker, I don't want to have some kind of web interface to interact. I just got a simple reverse shell to attacker box. What you see here is a hacker box. The below one is attacker machine, and the top one is basically a generic system. So I just running a simple nc command to basically get a reverse shell or like a listen for the container. So you see me, I'm already inside a pod. So once I'm inside a pod, so I just wanted to see how can I go more and discover what kind of things within the Kubernetes, right? You see me, I'm trying to explore what kind of operating system it is running, what kind of kernel it is running. These all are important. If you remember, still containers shares the underlying kernel resources. If there is a bug in kernel, still the containers gets exploited, right? So I am trying to look at what kind of container interfaces it has opened, like networking wise, and what kind of C groups it's running. This is quite interesting, especially by understanding this thing, where the container runtime is using. Is it really a container or like is a system? Is a specific container runtime? Is a Docker? Is a container D or Kata containers? There are so many containers, right? So this helps to enumerate and discover much more information about what kind of environment I'm running, right? So I also see a lot of processes running. If you look at like containers, that's not the matter, right? We need to only run specific process. And if you look at this just previous one, we see a lot specific process kube pods. But if you look at the different process, which is one of the system processes, you don't see it is running as a kube pod. Like I just took one of the process. The reason being the processes from the host system got mounted into the container, right? Which means you have host system processes access also, right? So, okay, it's all cool. Now I wanted to see what else I can do, like looking at any mount points, like anything's mounted from the host system to the container. Okay, looks like there is a bunch of things mounted, right? Which is good for me. So I wanted to see as many things as can I do. This is just a recon again, once you are inside a container, right? So, okay, once we have found it, like we also looked at what kind of capabilities available. Because this is something quite interesting. By default, containers doesn't have a lot of capabilities. So certain containers require extra capabilities so that it can perform certain functionality. Most of your detection tools, monitoring systems require capabilities like CAPSys ptrace, CAPSys admin, so that it can able to do profile tracing, monitoring and all. So as attacker, we can leverage the same capabilities, right? So what we are trying to do is, because it's mounted bunch of volumes and the etc host system, and also we have CAPSys admin. So I'm just standard old attack like chroot on the host system. Now you see I escaped out of the container. I'm inside the node, which means if you look at me, so I'm basically from pod, I'm already inside a node, which means I got a bit more access. So I privilege escalated from the initial discovery execution to the privilege escalation, right? So let's look at the next stages, right? As an attacker, that is not enough for me. Maybe I'm behind some data or behind some cluster admin access, right? So I just wanted to still enumerate as much as I can think of doing, like, okay, can I do Docker images? Because now I'm already inside the container. Maybe I can do much more, because not just one thing, I have much more access, right? So this is pretty much attacker will stop or red team will stop if their goal is to steal the data, because they have pretty much all the container data. If their goal is to take over the entire system or something, maybe they still continue, right? So I just showing in another way to attack, like in a center, the same attack for the container escape. So now if you look at it, Kubernetes has something called interesting concept called API server. If you remember, which I said, even the components of Kubernetes use API server to talk to it, right? As an add-on user. So what we are trying to do is we are trying to leverage one of the system component called kubelet. Even if it has to talk to Kubernetes to schedule one of the pod, it has to have some configuration so that it has credentials to talk. So as an attacker, I'm already here. So I wanted to just leverage the kubelet configuration so that I can talk to API server as a kubelet. So which means the thing that kubelet is talking rather than attacker. So I'm just leveraging the existing credentials of kubelet to talk to the Kubernetes API server, just giving much more privileged access to the containers, right? So you can see me like kubectl get parts. By default, it doesn't come. So whenever I start like using the specific config, basically I'm just passing the config of kubelet kubeconfig. And now you can see me, I should be able to get the parts because kubelet has the configuration to get the parts, right? Which means I got a bit more privilege than what I had to be, and which is quite good, right? So there is another hackish imperative command called auth-can-I in a Kubernetes, which is basically Kubernetes, by the way, entirely API driven. You can ask them what kind of permissions I have also. If you're someone coming from the cloud world, it's like enumerate IAM, like written by, I think, some dude from the security, right? Which kind of gives what all permissions has. So you can also do like, can I get, or can I delete, or you can just do can I list. It gives all the list of permissions that credentials has, which means whatever these permissions have, you can do as an attacker, right? So from here, I just wanted to see even if I can do defense evasion, means maybe someone might be detecting me. I just wanted to enumerate them. So I just trying to, you can just delete the logs of the pods because these are getting forwarded to somewhere to detect your attacks. So as an attacker, I can just delete these logs, right? Or I can just modify the configurations, or there is some specific techniques I think I haven't covered in this, but there are a bunch of ways how you can basically avoid the defense like in the Kubernetes systems, which they cannot detect, right? Cool. This is all fun. Then I don't just want one node. Maybe I have some sensitive workload like PCA workloads, which is in a different node, which no one has access. So now I literally wanted to move across the nodes, right? Not just on one specific node. So if you look at this, we are currently in the FNJZD. This is the node. So we wanted to escalate and laterally move into ZI, right? Which means we are literally moving into the different node from here to here, which means you can basically gain some more access, right? Similarly, you can go all over the nodes. Basically, you can complete cluster takeover, right? So that's the whole idea. But there used to be bug, by the way, called node admission plugin, which is fixed recently. Otherwise, you can just use kubelet config to deploy and hop onto another node, basically cluster takeover. But this got fixed. So now what I'm trying to do is I'm trying to get the node labels, which is basically most of the Kubernetes systems works with the labels and selectors. So I'm trying to take the label of the another node which I wanted to get deployed. So once I have this label, there is a really interesting concept called node selector, which means you can select which node you wanted to deploy certain pod. So this is again technology, right? If you understand these concepts, basically you can leverage this to take over the another node with the same native features of Kubernetes. So this is what I was saying, by the way. If you remember the besides CTF hack, as I said, if by default there is a service account mounted in var run service account token. So this is a simple JWT token. So using this token, you can give certain privileges to the containers. It's like, think of this instance profile or in the Kubernetes, in a AWS world, right? You can give instance profile credential. It's nothing but it has bunch of permissions. So as an attacker, I'm leveraging because it has even permissions to create something called pods, right? So what I'm trying to do is I just exported a bunch of these variables like namespace, certificate, and the JWT token. So once I exported, I'm just querying, can I able to talk to the Kubernetes API server using these tokens? Of course, I can able to do that, right? So now I just wanted to see if I can do a bit more things on top of that. Like can I able to get specific pods in certain namespace, right? Looks like I have a permission, right? So as an attacker, I just wanted to deploy a simple backdoor, right? And a different node which I wanted to have access laterally. So if you remember, as I mentioned, this is the label I am taking, like another node which I wanted to get deployed the pod. So this is a concept native feature in Kubernetes called node selector, which will help most of the machine learning teams and all to deploy workloads in a specific computer or specific node. So we leverage the same feature as attacker to leverage and deploy our backdoor in a different node, right? So you can just see me like putting a different node, which is the label. So I'll just go ahead and use the same curl endpoint and hit a backdoor.json, which is basically I'm taking the curl thing. So once I have this deployed, basically you can see this is already deployed. Pretty good, right? And I just wanted to again go back to host system. And because I already have get pod access in the host system, if you remember. So now I'll just go ahead and try if I can able to get the pods from the Kubernetes cluster, right? You can see. Okay, because it's in a different namespace, you have to check in the namespace which got deployed. You can see the backdoor pod is ready, which means we have a backdoor running in a different node, which we have exploited, right? So, and you can also see clearly, this is not the same node which we had. So we got deployed in a different node, and you can just set up a like host system privileged pod, again, get a full backdoor shell, and you take over the another node. Which means you not only started from initial, you got exploited, you got privileges escalated, you laterally moved across the cluster, and pretty much you have complete cluster takeover, right? So I don't want it to stop here. Maybe I just wanted to keep persist my backdoor, right? So this is also, again, the good old techniques doesn't apply in certain cases. Like, by the way, the namespaces in Kubernetes is a myth. Like, there is no segregation or segmentation. By default, it's a flat networking scheme. If someone is one of the pod, basically you can access the whole cluster, right? And most of the people think that, okay, it's segregated. They will leave Elastic clusters or like a Redis or MySQL open, or like they don't have mutual TLS. Basically, you have all the gateways open once you are inside a cluster, right? So cool. We have pretty much access to the cluster, and you took over the nodes, and you have complete cluster access. Now, what I'm going to show you is something called a simple server, which is a very old concept in Kubernetes called static pod. What it does means if you have a number of nodes in Kubernetes, like each node wanted to run some one agent. Think of this as a simple monitoring tool like Sentinel or something. They wanted to collect all the logs and send it back, right? They want to run in each server, whichever they started. So daemon sets are the concept, which is basically keeps one computer or one pod or one container running in each node. So in olden days, there is no concept in Kubernetes. They have something called static pods, which is not monitored by API server, because these are deal with the system level. So as an attacker, I can still leverage these static pods to basically keep persisting in the cluster. Because even though kill like the administrator, I can keep spinning up because it's managed at node level, right? So there are a lot of things. I think these are some of the techniques I'm showing is from very minimal, but in a real world, there are quite plenty of attacks happening like this, right? So you see me, I destroyed or deleted the pod, but you see just it got spawned up and running, right? So this is cool, right? So from there, I just wanted to show one more last attack. I think I'll just wrap it up given we wanted to show. By the way, you can not only just leverage the Kubernetes, you can even laterally move to cloud providers. So if you have like access to metadata APIs like the 169.254 standard IP address reserved for the cloud, so you can even steal those credentials, maybe whatever the permissions it has, which sometimes, by the way, has much more access. Basically, you even have access to their cloud providers where the Kubernetes clusters are running, right? So I just showing like whatever the instance metadata has, and I'm just running a simple STS get color identity to see what kind of access has to this. So you can see pretty much I have access to this cloud provider. So I just laterally moved horizontally, vertically. Now I just wanted, if I'm someone behind resource consumption, basically I wanted to make their services down, I'll just run a crypto miner or just hog their VMs by, I'm just showcasing with StressNG. You can see this, I can consume a lot of resources and automatically scale this, right? So now what I wanted to show you last job is like, I just wanted to keep a persistent backdoor, right? So there is a very cool concept called cron jobs, which is not as different from the standard good old Linux. So what it does, the difference is Kubernetes is a distributed system, right? So tomorrow this node can come up and go. They can just delete this node, right? Another node can come up. So the cron job idea is all the data, if you remember etcd, it will store key value pairs. So our cron job data also gets stored in etcd. Even if these all nodes deleted, they upgrade the cluster or backdoor still persists because the data is getting stored here. So we are leveraging the features of Kubernetes native technology like cron jobs of the Kubernetes. I'm just setting up a backdoor, which I basically always have a persistent reverse shell to my attacker box, right? I just changed it to parallelism always one, concurrency, which means no one want to see me always running a bunch of backdoors. So I just wanted to make sure one of them running always one. So I'm just running a listener in an attacker box and I'm just applying a cron job. You can see it got created and you got the reverse shell back, right? Even though if I just someone upgraded the cluster, someone deleted nodes, I have a persistent backdoor to the Kubernetes now, right? Cool. I think I'll just stop it here. This is quite a lot of hacks, right? So you can see this is quite good, right? So now we just want, oh, sorry. I went back, right? So how do you want to map it back to the defense, right? So I think there are a lot of layers. If you look at a defensive approach, right? You can't just go and fix like a runtime or container security. It's game over, right? Attackers will not say that, oh, because they don't have a tool for like supply chain security, I'll not hack that part, right? They don't have any boundaries, right? They can hack any of these things, right? So if you look at like the simple perspective, right? Attackers have things in like the tree structure, or defenders have many layers, right? Basically defense in depth approach, right? So sorry for that pun. So I just wanted to focus on one specific technique, how you can detect certain attacks, because we don't have much time. Definitely. I just wanted to showcase how we can detect these and maybe give you some resources so that you can learn some of the defenses for other attacks, right? Cool. So I think these are some of the things. Maybe I'll just show a simple live demo. As I said, I really prefer to do live demos. So let me showcase a simple cluster. Cool. I have a simple Kubernetes cluster, right? I hope you can see the font backside. Okay. So you see me, there is a one pod which is running here, right? And the below also same cluster or same container I am inside, right? So I'll just use something called Kubernetes Goat, as I said, a playground which I have created. So I'll just going to introduce that in a bit. So I'm just going to use some scenario called Cilium Tetragon. So what I'm going to do here is to just get started with this. So I will just go ahead and start the attack, just what we have seen here. Like I'll just exec into the pod. And then I just wanted to also monitor those attacks, right? I'll just quickly run one simple tool called Tetragon, right? So what it does is, if you look about the most of the modern container attacks, right, you just can't wait for a minute, right? In a matter of seconds, you saw me like cron job got like backdoor shell, and I could have like deleted and went back also. By the time your blue team might have get detected or like responded back, right? So you need a mostly modern defenses, especially more runtime security, or especially in terms of how you can prevent them than just detection, right? So I'll just showcase a simple attack. Same again, we are inside a container. So I just wanted to see if I can do bunch of things like same way. Can I do container escape, right? I just using the same attack. And you can see me, it just got detected that container attack. If I have written a certain rules like tracing policies, I could have even stopped a certain system call, even not just reporting. I just could have stopped this container call. So you need to advance these kind of detection mechanism. At least, by the way, this is just a simple tool by Tetragon from Cilium based on eBPF. But this is just an example of one case. As I said, there are a ton of the things you wanted to look at, right? So if you look at what we just did based on container escape, like from the host system, we have Tetragon, which is basically the eBPF based syscall detection tool, which is detecting all the system calls and able to understand, okay, some system call got executed. So you can also defend or prevent based on certain system call. You can kill them, right, before even it's establishing, right? Cool. There are a ton of things. I think as slides are going to be available, I'll just skip through them. Basically, you definitely can't just have like a static or slow monitoring system. You need to have different kind of logs, like different layers, right? So the best thing, one thing you wanted to start, how can you go back and practice these things? Because it's not very adaptive or available technologies in the world, right? It's not matured. So there is a project I have created called Kubernetes Goat, which is a fun playground to learn Kubernetes security. Basically, you saw me just one of the detection as well. It has a bunch of vulnerable scenarios or detection techniques, how you can learn and use them. So pretty much extremely documented. It's not just for attackers. You can also use for learning blue team detection and stuff, or also even vendors like Microsoft Defender Research use this to detect their capabilities. Like, is that really detecting these attacks, right? Pretty much we have 22 scenarios in the playground. Like you can deploy in any of the cluster which you wanted to deploy. As simple as just running a bash script. Please make sure to check them. And you should be up and running with the Kubernetes pods. Then you should have a playground up and running, right? We have a bunch of scenarios around almost various attacks like OWASP top 10 and also MITRE framework. So you should be able to learn each and everything by step-by-step documentation. As you see, some of the people like Microsoft Defenders use this to adopt. With that, I have a bunch of stickers as well if you want for the fun playground, but please make sure to spread the word. Thank you.